Hey guys, and welcome to our next set of video notes. Today is all about chemical equations and how to balance chemical equations. So we talked about chemical reactions in the last set of notes. Today we're going to learn about how scientists go through and figure out how many atoms are supposed to be on each side of our chemical equation. So with that, let's get into the notes. So like I said, today is balancing chemical equations, taking those equations that we were talking about the other week with the reactants on one side and the products on the other side, and making sure we have an even number of atoms on each side of the equation. It's a little bit tricky at first, but hopefully with my help and showing you how to go through things, you guys will be able to figure it out just fine. So if you remember from when we first talked about it, chemical changes, chemical reactions are where we take one set of substances, the reactants, and turn them into a new set of substances, the products. So the reactants over here are our starting materials, and the products are our ending materials. So we start with a couple different products, or reactants, excuse me. They react together and turn into, that's kind of what this big arrow thing right here is showing us, is that one set of stuff turns into a new set of stuff. And that is a chemical change or a chemical reaction. You may also remember from the notes last time is that chemical reactions don't add or take away any atoms. They just rearrange the atoms that we already have. So if you notice with this big complicated photosynthesis equation right here, we have the reactants. Remember, these are our starting stuff. We've got carbon dioxide, water, and some sunlight. That's what we're going to use for energy. And then on the product side, we use carbon dioxide and water to make sugar in the form of glucose and some oxygen that the plant gives off. And remember when we talked about it last week, I mentioned that on our reactant side of the equation, we have C, we have an O, as well as this O over here. And we have an H right over here. C's, O's, and H's on that side, which means that on our product side, we should only have C's, O's, and H's, which is what we see. So we have the same atoms on each side of the equation. We don't add in or take away any completely new atoms. We don't see any silver or gold showing up in the products randomly. It's always going to be C's, O's, and H's. But one thing that I didn't talk about last time is that if you pay attention to the numbers, you'll see that we have the same number of atoms on each side as well. So this CO2 over here has this 6 in front of it, which means that we apply this 6 to both of these guys. So we have 6 C's, and we have 6 O2s in total, which is 12. So we have 12 O's. And then on this side, we have 6 H2s, which gives us 12 H's in total, and 6 more O's. So in total, on our reactant side of the equation, we have 6 C's, 12 O's in our CO2, and 6 O's in our H2O, which gives us 18 total O's. And 12 H's from our water, our H2O over here. So 6 C's, 18 total O's, and 12 H's. Let's see how that fits on the product side over here. So we go to our glucose molecule first. We have, to start it off with, C6 right here. So we have 6 C's, no C's over here, so we're good there. We have 6 O's over here at the back. There's nothing in front, so these are just 6 O's. And right in the middle here, we have 12 H's. So 12 H's. Then the second part of the products, the oxygen that's created, we have 6 O2s, which gives us a total of 12 O's, which means we have a total of 18 oxygen atoms in our equation. 6 C's, 18 O's, and 12 H's. Should sound pretty familiar. You'll notice that this side, the reactants side, and the product side over here are equal. They have the same number of atoms on each side of the equation. That means that this equation is balanced. So writing and balancing equations is all what going through the steps today is going to be about. So, like we've already talked about a little bit, we have these chemical equations. They're kind of set up like a math problem, only instead of an equal sign, we use a big arrow in the middle. One important thing to pay attention to on our chemical equations are those big numbers that sit at the front of the equation. Those are called coefficients. So it is the big number that comes before the chemical symbol of a substance. So if we go back and look at our photosynthesis equation, we have 6 CO2 plus 6 H2O gives us C6H12O6 plus 6 O2. So these big numbers, these sixes right here, these are our coefficients. So the coefficients are a really important part of the chemical equation process. We'll talk about them a lot more in just a second. So the coefficients are our big numbers in front of each substance. Those little numbers down at the bottom, these 2s and 6s and 12s, these guys are called subscripts. And so the subscripts stay put in the equation. We can't do anything to those subscripts. They're set in stone, essentially. So if you see one on your equation, don't touch it, just leave it there. The coefficients, on the other hand, we're going to be doing something about. All right, so a lot of times when scientists first discover a chemical equation, they just know which atoms are involved, but they don't know right off the bat exactly how many of them there need to be in order to have the chemical equation happen. So in order to make sure that our chemical equation gets balanced, we can change the coefficients, those big numbers, in the chemical reaction so that we get the same number of atoms on both sides of the equation. So in our photosynthesis equation that we looked at earlier, that one was already balanced. It had the coefficients in place, and we had the same number of C's, O's, and H's on each side of the equation. If you're given an equation without any coefficients and you have to balance it out, there are a couple steps that I'm going to walk you through. So you're going to either write down, or in most cases, you'll be given a chemical equation. Figure out right off the bat how many atoms are on each side of the equation. So how many C's, O's, and H's are on the reactant side and the product side of the equation. You then are going to change the coefficients in order to hopefully get all of your atoms balanced. And then you'll recheck the numbers of each atom. If now you have the same number on each side of the equation, then you're all set and your equation is nice and balanced. If not, you need to go back in and change one or more of the coefficients to give you that nice balanced number. I know it's kind of hard to picture in your head, so let's go through a basic example to kind of show you guys how exactly you go through this process. So here we have a relatively simple chemical equation, and we need to balance mercury oxide, or HgO, as it splits up into Hg and O2. So we're given the equation, and the first thing that we're going to have to figure out is how many atoms of each element are there on the reactant side, which remember is these guys over here, and the product side, or these guys over here. So we call that checking for atom balance. So we have, like I said, Hg and O on our reactant side of the process, and Hg and O on our product side of the equation. So first we're going to look at our Hg's. We have one right here and one right here. Each of these is only one. There aren't any other numbers that are changing how many there are. So for Hg, we have one on the reactant side and one on the product side. Now let's look at our O's. We have an O right here and an O right here. This guy, there's just one O. Again, no other numbers around to change how many. This guy, however, thanks to the little baby subscript down here, there's two O's on our product side. Oh, sorry. So there are our Hg's right there. And then our O's, we only have one on the reactant side, but we have two on our product side. So that means this equation is unbalanced. There are not an equal number of each atom on each side. Our Hg's, our mercuries, are balanced. There's one Hg on each side, but our O's, our oxygens, are unbalanced. There's one oxygen on the reactant side and two oxygens on the product side. This is a problem that we're going to have to go in and fix by balancing this equation. So our issue is that we have two O's on the product side. We can't take away any O's over here and make it one because this coefficient, this little 2 right here, is permanent. It's stuck. We can't do anything about that. So what should we do? Well, we could add an extra O onto the reactant side. So let's try doing that. So we can add a 2 on the reactants so that our oxygen will have 2 of them instead of just 1. So we put a 2 as the coefficient. Remember, coefficient is the big number that we can change, that we put in front of the equation. So we put a 2 in front of our HgO. So since the Hg and the O are one overall substance, they're fused together, the 2 is going to apply to both of them. So it's going to apply to the Hg and the O in our reactants. So now, instead of having one Hg and one O on our reactant side, instead, we have 2 Hg's and 2 O's on our reactant side. So by putting this 2 right here, we added a second set of HgO to our equation. So now we have 2 of both of our reactant molecules. So this is great for our O's because now our O's are balanced. We have 2 O's on the reactant side and 2 O's on the product side. So that's good. But yikes, our HGs aren't balanced anymore. Now we have 2 HGs on the reactant side, but we only have 1 on the product side. So we're still not balanced. There's one more thing that we have to do in order to balance this out. Luckily, it's pretty simple. We can add a 2 to the HG on the product side. So we have our 2HGO on this side, just like we did before, but we can add in a 2 coefficient over here in order to give us 2 HGs on the product side. So our O's stay the same, right? We had 2 O's before on each side. They were balanced. That was good. We have 2 HGs on the reactant side still. That didn't change at all. But now, instead of having 1, we have 2 HGs on the product side. Now, let's check to see if our equations are balanced. We look on our reactant side. We have 2 HGs on the reactants. We go to the products, 2 HGs on the products. That's good. We go to reactants. We have 2 O's in our reactants. We go to our products. We have 2 O's in our products. So now we have a balanced chemical equation with 2 HGs and 2 O's on either side of our equation. So that is how you balance a chemical equation. You start off with your original equation. You check the atoms. In this case, we had too many O's on our product side. So you try to fix it. We added some more to the reactant side, but this caused our reaction to become unbalanced again because now our HGs are no longer balanced. So we added a 2 to the HG on the product side, and now our equation is totally balanced. So we checked our number of atoms. We did one change in order to fix it, checked again. It wasn't quite fixed yet, so we changed another coefficient, checked again, and then we were fully balanced. So remember, to have a fully balanced chemical equation, you have to have the exact same numbers of each atom on either side of the equation, on the reactant side and on the product side. So one more thing to note about balancing equations that you may have picked up on while we were going through the photosynthesis example early on. So if you ever put a coefficient in front of an element that has a subscript on it, that little number, like this 2 down here, or this one right here, then whenever you're figuring out atom numbers, you multiply the subscript with the coefficient. So for example, if we have 3 O2 molecules, 3 times 2 is 6 oxygen atoms. If we have 4 water molecules, remember we apply the 4 to both the H and to the O. So in this case, H has a subscript. So 4 times 2 is 8 H's. O does not have a subscript. So the 4 just gives us 4 O's. So that's how you deal with elements that have a subscript when you change the coefficient in front of them. So that is all of the notes that we have on balancing chemical equations. So I know that it seems a little bit tricky, and it is, I'm not gonna lie. This is one of the things that I really wish I could be in front of you guys to go through, because I know you probably have a lot of questions at this point. If you see on the assignment page on our Google Classroom, I've also posted a link to 2 different videos that I think do an equally really good job at explaining how to go through balancing chemical equations with dealing with your reactants and your products. And so I just wanted to give you kind of a quick overview of the homework that you guys are going to have, which is basically just a whole bunch of chemical equations that you are going to be in charge of balancing and figuring out the correct coefficient for each equation. So let's go ahead and look at what that looks like. So here is our balancing equations worksheet. And so for each one of these equations, you're going to go through and kind of like I just did with the notes, figure out how many of each atom are on each side of the equation, and then change the coefficients inside of these boxes in order to make sure that the number of atoms on each side match. So the first page of this kind of lays everything out for you. The second page of this is more of the same, but you're going to be writing more stuff out on your own. And so if you can figure out how to balance them right off the bat, then go for it. But if not, you can go through the same process over again of writing out how many atoms are on each side and then changing the coefficients in front of the atoms in order to make sure they are balanced. So one quick thing about this worksheet, you do not have to do the challenge equation down here. You can try it if you want to, if you want to see if you're really able to do it, but it's not a required part of your homework. All you have to do for homework are these 7 questions on the back and these 4 questions on the front. Now I mentioned these 4 questions on the front, even though there's this 5th one up here, because I'm going to go through this one with you guys right now, for those of you who are watching this video, as kind of a bonus to give you a little bit more practice of seeing how this balancing equation stuff works in person. So here we have another pretty simple equation. We have Mg, magnesium, and O2, oxygen, are going to fuse in order to become MgO. So what's the first thing that we do? Go through and figure out how many atoms of each element are on the reactant side and the product side. So if we go to our reactant side, we have just the one Mg, so we'll put a 1 here. And we have 2 oxygens, thanks to this little subscript right here. So we'll put a 2 for our oxygen. Over here, we have a fused MgO, but we still only have 1 Mg and only 1 O. So our Mg's are balanced. Great, awesome. Unfortunately, our O's are not balanced. We have 2 on the reactant side, but we only have 1 on the product side. So let's fix this by going over here to our product side and saying, okay, well, I don't want 1 oxygen. I need 2 oxygens. So I can put a 2 in this little box right here. Or maybe it's not going to let me put it in the box. That's okay. We'll put a 2, pretend like it's in the box. 2 for our equation right here. So now that 2 applies to our oxygen. So yay, we have 2 oxygens now. Unfortunately, this 2 also applies to our magnesiums, our Mgs. So we have to change this magnesium to a 2 as well. Boo. Now our oxygens are balanced, but our magnesiums are not. So we have to come back over here to our equation and say, okay, I don't want to mess with the oxygens at all, but I need to have more Mgs in order to make it balanced. So we can add a 2 in front of our Mgs right here. And now we have 2 Mgs So we can change this guy into a number 2. Now we double check that we're balanced. 2 mg's over here gives us 2. 2 mg's over here gives us 2. Awesome. O2 gives us 2 oxygens on this side, and the O goes with this 2 coefficient right here, gives us 2 oxygens on this side. So now our equations are balanced. We have finished balancing this chemical equation. So that's basically the steps that you're going to go through for each one of these chemical equations in this worksheet. Figure out how many of each atom are on either side of the worksheet. Change the coefficients in order to try and make it balanced. And then double check that you've got the correct number of atoms. And if they're still messed up, go in and change another coefficient and see if that will balance it. Okay. So hopefully with these instructions and with the extra videos that I'm going to post for you guys, it'll make things a little bit more clear when it comes to balancing chemical reactions. As always, please reach out to me if you have any questions or you're having trouble with this. You can send me a text, you can send me an email, or you can leave a question on the assignment on Google Classroom, and I'll try to answer them as soon as I see them. You can also come to one of our Zoom office hours that we have multiple times a week during the week. Or if you're unable to come to those, you can always set up a time to meet with me one-on-one, and I can help you go through some of it. Once you're ready to turn stuff in, remember, you can email it, you can text a picture of it, or you can upload it directly to the Google Classroom assignment page on there. So that's all that I have for balancing chemical equations. Again, please reach out to me if you have any questions. I know this stuff, it's a little tricky, and I'd be more than happy to give you some more explanation if you need it. But with that, good luck, and I will see you for our next set of notes next time.